Hello and welcome, my name is Dominik, and today I will show you how to train models with Roboflow and YOLO V5 for the search and rescue application for the USV Lear. And I'll kind of go through Roboflow, the platform and the features. So first, if you go and sign in, and then we will create a new project, and will be created on the front page here. So we select the object detection, that's what we're going to use. We're going to be detecting people, boats, kayaks and the USV, which is the drone boat that I'm working on. The project name is, or just call it whatever you want, I'm going to call it USV Lear Search and Rescue. And the license, it's really good here, you can pick your own license, whatever, but it's Roboflow has the projects are open source, so you can see other people's projects. And also, like I'm using here, I'm using the aerial floating objects dataset from Kaggle. I'll have that linked in the description. So this comes in 3 parts. It's a big file, around 3,000 images. It's annotated as well, so it's really good. One step less for us to do. I'll be training this model fully on Roboflow and getting you through the process. So here I'm just showing you the text, the names, the labels that are used. So there's different category names. I think we'll be using this one, so the human, board, boy, sailboat and kayak. And yeah, so in Roboflow we're just going to select a folder with all the annotations and images, and Roboflow will handle the matching of the images and annotations for us. So it's going to process them. We're going to skip this. We're going to go straight to the split. So you're going to have to split into your train, valid and test. Basically the training split is the images that are going to be trained, obviously. The valid is going to be during the training, is going to see the parameters and the way they go, and tune them if it's, to improve the score. And then the test set is what's going to be evaluated. So right here we were just waiting for it to finish uploading. Now we're gonna see, we're gonna generate a version of basically our project with all the images. So here we can do some pre-processing. I like changing the size of the images. Obviously that'll make our training a lot faster. We saw that we have around 3,000 images, 2,000 in the train set, and then split. So augmentation options, we can kind of add a bit of noise, saturation, hue, play around with those values, and it'll generate new images for us. We're going to see that later on. Right now we're just going to use just the images that we have, no pre-processing, no nothing. We're just going to make a model. There's no USV in here at the minute. That's because we still haven't collected the images. That's going to happen later on. We just want to see how good this dataset is. Now the people that made this dataset, they also provide a Python notebook how to train it. I'm using Roboflow because I started liking it, because it's a lot easier. So now we can see in the health check some info about our images, and how big, like the pixel size, the average size per image. All our images are pretty much the same size. If we go to train the model, we have an option of a fast or accurate. Fast for us because it's offered as free with Roboflow. We're going to train from a public checkpoint, which is basically a pre-trained model which already has some knowledge of what some things are. So it maybe will help us like recognize a boat or a person in the water, and it has some ways to pre-configure. We can train from scratch as well, but we won't do that this time. So we're just going to start the training. This process we're going to skip. It's just going to zip the files to start the training process. Good thing is it emails you, so it can take anywhere from 10 minutes to 24 hours. I usually had it within 3 to 4 hours. Sometimes even less, depends on how big the model is. This one has actually the longest because the amount of images. I've trained other ones with around like 100 images, but the more images obviously the better the model is going to be, and the more sure you can be that it actually learns something. So here we have a training graph. After each iteration, after each training step, it's going to give you a little score from the validation set, and at the end we're going to get the overall score from the train set. So we can see our metrics kind of going up and down. Ideally you want it to go obviously up as high as you can. So here as our final scores, which is not bad. Now, we see in training graphs are pretty smooth. You want them to be as smooth as possible. The loss graphs going exponentially down, and the precision accuracy graphs going up. Now, if we see Roboflow offers a lot of deployment options, such as this API kind of interface here, we can actually put in our webcam directly into on the website and start inferring objects from there. We can export this, and we're going to talk about this later when I'm training the model locally. And here we can see the deploy tab, where we can actually see the samples from the test set and see how accurate they are. So we can increase our thresholds. So you can see it's pretty good. 83% confidence on that portion there. We can also see the predictions JSON object. That's how it's returned, and that's how I access it in the application in the code. I have to parse that, and from there you get your x coordinates, y coordinates, and your dimensions of your rectangle. Now, this is the code that Roboflow offers. If you first have to do a pip install, if you're using Python, pip install Roboflow and import it into your project, and then you can add it like they provide, like this, like so. I'm going to be adding it right now. It's going to be sped up, but I'm going to be adding it to my graphical user interface, which is essentially my project that has all the path planning in it. And you will see some tests later. So we're going to test the data set now on some unknown YouTube video. I'm going to select it after I did it to the project, and here we go. Now this is sped up. You can see the mouse moving really fast. So it's still pretty slow. Even if it's sped up, it's still, but Roboflow is running in the cloud, so we have to be always connected to the internet and sending up the image to Roboflow and back, and again the predictions back. So it's not the fastest, but it is really accurate. Yeah, so this, you can see how fast that video is. Now we're gonna go to the section where I'm collecting the images. So we went out on a test and we collected the images from a drone, and now I collected about 34 images, so we're gonna see it here. So right now our model has only people images, and I have some captures here from a video. I only pre-processed them in Lightroom just to change the color of the water, just to appear more blue, not grey. It was pretty grey day when we went out. So I have a folder, and so I made up, doubled the images, so it's about 64, and we're still going to add some pre-processing augmentation because it's really not enough images. But they're not annotated, so that's another step that we're going to do, and I'm going to show you how Roboflow's tool for annotation. So we can see they're not annotated there, and we're going to save and continue. And upload them. I'm going to skip this part. Now, the great thing is, if you're working in a team with Roboflow, you can actually invite teammates and they could help you with annotating. So obviously, if you have something like 3,000 images, it's kind of pain to do it yourself. But this time, if you have a cup of coffee, you can just grab it and sit down and just start annotating the images, listen to some music. Now, we're coming out here, and one by one, we're just going to draw a rectangle around every image. So you can see our classes here, and we can do polygons, smart polygons. So there's a lot of AI tools now coming out that actually work with Roboflow, and they're able to annotate the images kind of with you, let's say. I'm just going to do it by hand, and yeah, so one by one I start doing the images, and you're going to have to watch me go through all the images. So now, once we have all them annotated, we're gonna add them to our data set. Now, the train, valid, and test. Because we have so little images, we want the valid and the test to be bigger, especially the valid to be bigger than usual, because we have to validate, see if we're actually getting right predictions every time we train. Going back to the generating, so on the same, basically on the same project, we're going to generate a new version, add in some pre-processing, adding some augmentation to the images. So I want to change some hue, I want to rotate the images a little bit because I didn't maybe have all the rotations of the boat. We're going to change some brightness settings, we're going to add some noise, just to make this generalize maybe just a little bit if we're testing out in different weather conditions, let's say. So our final data set ends up being something around 7,114 images, and that's because all of the pre-processing happens on every single image, right? So we generate this and then we can start training. Maybe I forgot to mention that every time you train it takes away 1 credit from you. I want to thank Roboflow. They gave me a few extra credits here for this project, and yeah, so let's train from a previous checkpoint. Again, fast option. Previous checkpoint means because we have already trained this model on the data set and we've just added something else, I'm going to test it to see if my training from the previous checkpoint actually maybe improves the accuracy. Okay, so we saw the graph go there, it's started training, and now we're on to testing. So we're just going to test what we have now with our Roboflow models being in the cloud. Once again, I'm picking up the search and rescue. I'm just changing my version in the code, so it'll pick up you have to always change your version in the code. That's one mistake that you can do. So we can see here, this is in real time, I believe, yeah. So it's picking up the USV, but it's pretty slow. I mean, if this was actually going to save someone's life, and that's how it was given the directions, and it was going fast, it would have been receiving its messages late. But we can see it also picked up the USV from an unknown image, the blue one. So it was pretty good. Now we can see again with the unknown image, it's performing a little simulation. So I made this simulation just so I don't have to test with any robots or any actual boats. Just I can test it in code if the path planning actually works. But I just wanted to show this, that it actually recognizes the 2 people from the test. They're from the test set. I just added them in, and it's pretty recognizing, pretty like, you know, every frame. So the USV is not recognized every frame, and that could be also because of the background. It's not on like water or anything. It's pretty grey. But yeah, in the last test you've seen that the person was misclassified, let's say. So yeah, just to finish off this mission, it should stop when it reaches the people, and yeah, that's the mission done. But obviously in this situation I'm just moving the boat whenever it gets detection, so the boat doesn't have any velocity or momentum. So now this is when we brought it out for a real test. This is actually in real time, and the video is not moving because of the communication error or the comms being very weak. So there's really poor internet on the site that we're testing, and honestly I thought the video stream would be better, and we weren't able to stream it to YouTube. So we kind of used this technique of putting it to the webcam, but you can see the boat was recognized pretty well. So it proved that it worked. It was just an issue with the comms. So if we use something like 5G or something like that, and if there was 5G coverage in the area, we would have no problem. Now, so the limitation here was that it was really slow using Roboflow. It was really accurate, but with the limitations we don't have good networks, like 5G is not really in place, so we're gonna try it on a local model. So I'm going to show you how to do it with YOLO V5 from Ultralytics. So first you're going to download this GitHub repo. It's going to download the YOLO version 5 folder. I think there you're going to have pre-trained model. You're going to have all your scripts to train, detect, and export, and all that good stuff. So once you have a version in Roboflow, you can export it. So I'm using YOLO version 5 PyTorch here. It's going to download all the images already split in their folders. They're train, test, and valid. It's going to give you a YAML file with the configuration, and it's really easy and nice to set up. A lot easier than trying to manually set it up yourself with TensorFlow, like I did at the start, and I won't be covering that in this video. So I'm importing this dataset and it's going to download. So we're just going to wait a little bit for this to download, and yeah, so I skipped over that part, and we're going to head into training. So we're going to pass it in the data folder, and then I'm doing this in Colab, by the way, but we'll see. You're going to see. You can do it in Colab if you want. It's really good because you get access to the resources I'm going to show you here, the GPU, RAM, so they're virtual resources. However, I'm trying to train it here for 100 epochs, iterations, and you're going to see that it actually froze on me after running for 12 hours. So running it on like 6,000 images for 12 hours, for 12 hours on Colab wasn't enough. I tried to run it now on you can see this screenshot on my local machine. This is after 24 hours. I only did 3 epochs on 6,000 images. So, you know, it's not. My machine is a MacBook Pro M1, by the way. So, you know, it's not ideal. You probably want something with a GPU to be trained on your local machine. However, I did move on now to still using my local machine, still the same way, but on the paper dataset. So it's only detecting the person and the boat at the paper version that I have the little cutouts. And we're going to see a mission of that as well. So same way, I export it, I put it in, and we put in the weights. So that's the YOLO version 5 pre-trained model weight, the image size, the epoch. So I'm gonna do 100 now, and the batch size is, we're gonna remove the freezing, and the batch size is 32, which is the amount that gets loaded into at one time into the training. And we're gonna cache the images. So we're gonna for the training, just for the duration of the training, the images are gonna be in memory. Now I ended up training it in my terminal, and here are the results. So I think I only trained for 50 epochs because I think it crashed for me. Yeah, it crashed for me. Now we see in the runs exp number, the latest number, we see some results of the data. So we can see the confusion matrix. Sometimes the USV gets confused for being a background. Sometimes the boat gets confused for being a background. We see our F1 scores, our hyperparameters, and all these good stuff, the training, the loss graphs, and the precision graphs. So we can see some training batches and validation batches. So now in the weights, this is actually even the most important because it's the last weights for when this was last trained, and the best. So obviously the best accuracy, the weights were saved. So that's actually really good. That's why we're going to be used for exporting. But there's a script there, detect.py, which you give it a source of the test, all the test images. Then you give it the weights. You're obviously going to give it the best weights, and you're going to give it the confidence that you're happy with. So confidence means basically what percentage are you happy that it's classified as an object, basically, and you're going to give it the output directory name. So that will go through all our images in the test set and show us its predictions, and so we can visualize them. I just spelled something there wrong. I forgot a dash. There we go. So now you can go back into the folders in the YOLO version 5. So that's all done in there. So that's from that GitHub link. I'm going to link it in the description anyway. So we can see all those images. They're getting recognized pretty well. 79, 88. So now we're going to export this. So to use this with OpenCV, we're going to have to export it into a certain format. So everything is still working in that repo. With the export script, we're going to export the best weights, and so the weights are essentially the neural network, and we're going to include the ONNX, and that's going to give us basically the export, and we can use that now in the project. We can also see this in the PyTorch hub if you want to kind of explore this further. So this is a test of a local model in real time. So you can see how much faster that is. And we can see it's pretty accurate as well. USV 0.91, percent 0.9192. And the mission is also successful here, and it gets lost from time to time. It's because of the compass module that I'm using here. It comes directly from the microbit, and yeah, there's some magnetic interference with the motors at this point, but it did manage to sort of reach the person. Here we go, and it will stop. And yeah, that was the mission successful. We're moving on to training our model with the big data set. So what I've done is I made a little script that will only take out 150 images at random from people and kayaks. So I filtered by the annotations, and only like 150 of the process. It only took about 6 hours to train 70 epochs with 300 images. So you can see, you know, the mean average precision for up to 50 is pretty good, but from 50 to 95, you know, it's alright. The USV actually is pretty good here, 89%, but the people, no. So the curves pretty smooth for the box and CLS, but for the object, not very. The precision and recall, they also could be better. We can see a little big drop. That's because we're just using very small amount of training, you know, iterations, and a very small amount of images. Like 300 images is still a small amount for an object detection model, especially for this use case. But we have a real version, and we're going to do some testing on it. Well, first we're going to give it the DJI, well, the feed from the drone, and from this feed from the drone, we're just going to see that it's pretty good, and it's a lot faster. If you were to compare this side by side, I don't have a comparison right now, but if you were to compare this side by side to the one that we've seen just a few minutes before, it's a lot faster. It's still not real time, like you can see the slowdown, and it drops, but you know, it's a lot better than using the online model. However, it's less accurate, but it's doing the job right now. If we test it on some people in water, so this image from this video from YouTube is going to have a lot of people. Now we're going to start path planning. This now, yeah, this is glitching out on me right now. Okay, there we go. So, you know, it does depend on the height the person is, the size of the person, because the data set I trained on, the one that from Kaggle, it's pretty high up. The people are pretty small. So yeah, and then okay, we're gonna finish off right here. I'm just gonna show you the training graph for from the one on Roboflow. So see, this is really smooth. Our one wasn't that smooth. So thank you for watching the video. I hope you learned something, and if you have any questions, reach out. And yeah, thank you.